Wise networking. I'm just going to go over something real quick that I kind of went over last week in a video with this whole enterprise network I have going here. What I did last time is what I explained is I took each of these branches and connected them using OSPF and then connected each branch using OSPF routing. This time I did it a little bit different where we basically use OSPF inside this headquarters branch here and inside this data center here, but to connect the enterprise to branch 1 and branch 2 and to the DC we used BGP, which is the border gateway protocol that we use. So basically we have OSPF running in here and in here. Up here is just a router on a stick method for these VLANs, router on a stick method for these VLANs. Like I said, OSPF here, OSPF here. And then we use BGP to route everything else. I'll kind of show you a couple things. So these switches in here are going to be the same. How we set up, all these VLANs, 10, 20, 30, 40, 50, 60. That's exactly set up the way we had it the last time I went over this. We just did the routing between the branches differently. That's the only thing we did different. So that's basically all done on these internal edge routers here and this carrier router. There's a couple things I kind of want to go over quick just to show you. So if we do show run, and I'll get down here. So this BGP routing. So right in here we have this OSPF, is what we had on there before. And there's a couple commands in here I kind of want to go over because I missed them the first time going through. So I just want to kind of show you what I did. So in this router where we did the OSPF, so here's where we did our OSPF routes right here for that internal part. And then for the BGP, we do this where we actually, on this router here, what we do is once we name the BGP after this, here's the autonomous system number. So your command is just, BGP router 65001. It puts you into the router mode, into that router. And then we type the neighbor. And this neighbor is going to be this interface right here to this carrier, which is this 10.0.3.2, and remote autonomous system to 6500. So we're putting the neighbor of this interface and the neighboring autonomous system to get those to connect. Now the one thing that I had to kind of go back and do in this router was right here. You want to make sure you redistribute the OSPF1 so it learns everything. It learns all the OSPF routes also coming out of here. So now all these devices in here uses the OSPF to get to here, and then BGP gets it out. So that way these other routers, it'll learn that path. And then also in the OSPF side, I did a redistribute BGP 65001 subnets, and I also did this default information originate. And the reason I put that default information originate in there is it gives these guys automatically gives them a static route to the internet, which is my loopback address of this internet router here, which is 100.100.100.100, which is simulating the internet. So those are the two big commands that I missed the first time that you've got to kind of make sure you put in to redistribute everything. And the reason, I'll show you the route. And that way it grabs, and that way it gives you that one right there. And actually that one comes from this carrier router, and I'll show you why. But that way when it redistributes all the OSPF, you can get down in here to reach all these devices from outside. So when you go to the carrier router, just enable. You can't type. So for this one, we're basically just advertising the neighbors here. So you want to do each neighbor. So you got the neighbor, this one right here, which is here is the 10.0.3.1 remote autonomous system 65001. And you do that for each one. So it's this port, this system number, this port, this system number, and so on. And this right here, giving that a network 0.0.0.0.0. Once you give it that, it will then send this, because this is a default route to the internet, it will give that route to everything below it. So it'll give it here, like we already looked at it there. Through BGP, it gave it that one. And then if you go here, see switches. Oops. This one. So I do a show IP route there. And you can see it's getting all of these where it says that E2, because that's coming from like a redistribution. And that's kind of why you're getting all of those through OSPF. And it gives that one right there, because we redistributed the OSPF, or I'm sorry, the default originate command gives this route because it comes from there. So it kind of gives it a default route, basically stepping back from one to the other, like you give it that redistribute and the default originate, and that's how that gets that default route. And then the same in all of these. And since this, like this one had the OSPF where I didn't have to like advertise any of this network down here, I just had to redistribute it. So on this one, I did this one up here. Once I did the neighbor of 10.0.17.2 with this remote autonomous system 6500, which is right there, then I advertised these networks, which is all these 172 numbers here. I probably could have done that in a summarized route. I was having some issues with it, so I just did each one individually. So basically the command is, after you do this network, after you're in the router BGP, I did the neighbor, and then I just advertised this network with this mask, this network with this mask. And I did the same for this router. Did the same thing here. To advertise those. And let's do. So then when you advertise all these routes, it picks up all these BGP routes. It's because it's kind of like OSPF when it recognizes a neighbor. It's the same type thing, so it gets that through BGP from here to here. That's why I have all these addresses here are for my servers that are all in the data center. These are these point-to-point networks here. And then these are all my end devices here. And then these are my point-to-point networks inside this data center. And it also gets that static route by that, since I advertised that network 0.0.0.0 in the carrier router. And in here we kind of had to do the same thing with the redistributing. of the OPF. In the OSPF, we redistribute the BGP subnets. I give it this default information originate because that will give my leaf and firewalls down here. It will give them a default route to the internet. And also in my BGP, I redistribute my OSPF. So that way it redistributes these routes. So everything can get to the internet and to that carrier router. So if I kind of show the route in this leaf, you can see all these E2s, that was the redistributing. Redistributed my OSPF routes there so they could go to the other networks. So you can see that's all inside there, and it's redistributed just all this OSPF inside. And it also gives it that default route right there, going out either way. So as you can see there, everything kind of connects. In here I was testing my pings. So you can see here I pinged another device on a different VLAN inside the headquarters. This is another one, .30.11. These are all inside the headquarters but on separate VLANs. 50.12, so those were all pinging. I could ping the internet right there. I could ping my servers right there. And here I pinged outside. This 104.11 would be in branch 1. So those all pinged. And this 130.11 is over in my branch 2. And obviously the servers are in the data center. So I have pinged back and forth all over there. And this kind of works the same with the I waited too long, but basically this, I still have the same NAT protocol in here, which takes my private IP and turns it into a public IP. I'll go ahead and ping the internet, and I will quick show that. It times out, that's after so long. So. And there you can see it. So it took my 172.10.12, which is my inside local, and changed it to this public inside global 203.103.113.2 as it went to the internet there. So it's changed that from a private IP to a public IP, and that's all done inside of the carrier. Here we did this the same when we did the OSPF. We did it right here. So we just give it this IP inside sourceless one overload. And this here you gotta have in the carrier too, which is a static route to the internet. And that is how BGP works. It's kind of like, it's similar to OSPF. It works on autonomous system type setup. That way you keep OSPF in the internal branches and then BGP to route out more used like an internet protocol. That's what uses BGP the most. So that's how you set it up. Thanks for watching. Give me a like and subscribe, and I will talk to you later.